Hey guys, it's Maxi here, and I'm going to do some of the example problems to help you on the stat quiz. So for the first problem, we have Harley-Davidson motorcycles make up 14% of all the motorcycles registered in the US. So I'm going to circle that. You plan to interview an SRS of 500 motorcycle, so that's the sample size. How likely is your sample to contain 20% or more who own Harley-Davidson? So we need to check if this is normally distributed so we can use our normal CDF and z-scores. So let's do that using the normal condition. We know the normal condition is NP must be greater than or equal to 10, and N times 1 minus P must be greater than and equal to 10. So N is 500, and P is 0.14. When typing in 500 times 0.14 in the calculator, you get 70, which is greater than 10. 500 times 1 minus 0.14, that's going to be 0.86. So 500 times 0.86 gives you 430, which is greater than 10. So that is good, and you have your normal condition met, so you can start using z-scores. So when you're using z-scores but actually normal CDF in your calculator, you're going to need a mean and standard deviation. So your mean is just your probability, since this is a proportion. So your probability of getting a Harley-Davidson is 14%. So our mean is 0.14. Our standard deviation is this formula that would be very important to memorize unless it's on the formula sheet. And that formula is the square root of P times 1 minus P over N. So our P is 0.14, our 1 minus P is 0.86. So 0.14 times 0.86 over our N of 500. And you take the square root of that. So I'm going to do that. We get 0.01552. So now that we have a U and a standard deviation, we need to find our bounds. So 20% or more. So our bounds are 20% to infinity. So let's do that using z-scores. So we write it as the probability of z, and it needs to be greater than 20%. So greater, 0.2, minus our mean of 0.14, over the standard deviation of 0.01552. So if this was a quiz, you would actually calculate this number out, but I'm just not going to do that right now. So what you actually do, you just write that out to notate it for Ms. Round. You go to your calculator, you go to normal CDF. Your lower is 0.2, your upper is 1E99, your mean is 0.14, your standard deviation is 0.0. Is that a 2? 1,552? It's a 1, I put that. So you get 5.5 e to the negative 5. So you know that there's a 5.5 times 10 to the negative 5th chance to have a 20% or more Harley-Davidson distribution if you pick 500 motorcycles. So for the next problem, this is more of a general problem. So what we have here is, at a peanut butter company, the weight of a bottle is approximately normal with a mean of 16.1 and standard deviation of 0.15 ounces. So is randomly selecting a single jar or selecting 10 jars finding the average weight more likely to produce a result of 16 ounces? So you don't actually need math for this. You're going to know that choosing the 10 jars is going to most likely result in being less likely to produce something less than 16 ounces, because we know as our N increases, the variability of our data increases, because numbers over here are going to be canceling numbers over here, and it's just going to be getting closer and closer to the mean, so that bigger number would hold true. So I'm just going to, instead of writing z-scores, I'm going to write it as calculator jumble. So the probability a single jar weighs less than 16 ounces. So we know our mean is 16.1 and our U is 0.15. So U equals 16.1, standard deviation equals 0.15. So normal CDF, our lower would be all the 1E negative 99. I'll write it over here. Lower 1E negative 99. Our upper would be 16 because we want the range of less than 16, so all the way from negative infinity to 16. Our mean is 16.1, and our u is 0.15. So for the probability 10 jars weighs less than 16 ounces, we already know our bounds of our normal CDF. It'll just be lower 1e negative 99 again, and upper 16. But what does our mean and standard deviation change to? So if you recall the central limit theorem, you'll remember that the mean equals the mean of the, the sample size, and then the standard deviation equals the standard deviation over the square root of n of the sample size. So our mean is once again just going to be 16.1, and our standard deviation is going to be the old standard deviation of 0.15 over the square root of 10. So if you do that in your calculator, you get 0.047 and then some jumble of numbers. So since the distribution is already approximately normal, you don't have to do any weird things with n is greater than 30 to say if your sample is going to be approximately normal. So for the next page, we have one last problem here. It's, I'm struggling. What is this? It says, suppose the number of texts in a day by a random high schooler has a right skew distribution with a mean of 15 and a standard deviation of 35. How likely is a random sample of 50 students going to yield more than 1,000 texts in a day? So first, we need to know if this is normal. So using the central limit theorem, when a sample size of n is greater than or equal to 30, despite any distribution, even if it's like right skewed, we know that it's going to be normal. And if we look, our sample size is 50, and since 50 is greater than 30, this is normal. So we can use our normal CDF shenanigans. So let's do that. We need a mean and a standard deviation. Well, so the mean, that's just going to be 15. The standard deviation is going to be, remember, it's just the standard deviation of the actual divided by the number of students. And our sample size is 50, so 35 divided by the square root of 50 is going to give us 4.95. So now that we have a mean and a standard deviation, we're going to need bounds. So we know it's more than 1,000 texts in a day. So when you're looking at this, you may not know because it's 1,000 texts over 50 students. But what you can do is you can do 1,000 texts divided by the 50 students, because that will give you the average amount of text per students, which is what you already have. You've calculated the mean for the average student and the standard deviation for the average student if you have your sample size of 50. So 1,000 divided by 50 gives you 20 texts. So you're looking at bounds where the lower is going to be 20, and then the upper is going to be infinity because it's greater than 20. So if you wanted to notate this as an actual z-score, you would do the probability of z, and it needs to be greater, so you'd put greater, and then it'd be 20, because that's the average, minus 15, which is the average, that's like the actual average, divided by the standard deviation of 4.95. So when typing this in your calculator, you just go to normal CDF again, lower 20, upper 1e99, u is, let's see here, 15, standard deviation is 4.95, paste, and you're going to get 0.156 is your final answer. So that's all. That's like, if you can do and understand these three problems, you should be able to do everything else on the sheet and do well on the quiz. If you have questions, just like ask in the chat. Thank you.